Hi, everyone. Thank you so much for joining me today to talk about proof testing for safety instrumented systems. We'll discuss how we work through the functional safety lifecycle to determine proof test parameters that are part of our design calculation, and ultimately create a proof test that we can carry out on site to make sure that our SIF devices are functional and able to respond to a hazardous scenario. We'll also talk about the data that we collect during the O&M phase to ensure that on-site we're meeting our safety integrity requirements. I'll start by introducing myself. My name is Kate Hildenbrandt. I am a product manager for exSILentia software at exida. And that means that part of my responsibilities are to define requirements for new features within our software tools, as well as optimizing existing features. I also provide training instruction and software support. I've included my email address at the bottom of this slide so that you can easily reach out to me with any questions you have, whether it be about this webinar, one of my past webinars, or just general software questions. I will be happy to help with that. I want to address proof testing in this webinar because it's a really important part of ensuring that our safety instrumented functions are able to properly respond to a hazardous scenario to bring your process back to the safe state. And a proof test or a functional test is a manual test that we're performing on your SIF devices to reveal any dangerous undetected failures that may have occurred while the devices were sitting. Dangerous undetected failures are failures that cannot be detected through automatic diagnostics. And so the only way that we can reveal them is by doing this manual test. As we work through the life cycle, as defined by IEC 61511, we start to create our proof test strategy through SIF identification, documenting of requirements, and then ultimately creating our SIF design, which includes some of the maintenance activities we're going to carry out on site. Once we define the intervals at which we're going to do these tests, the procedure that we're doing the test for, and once we've implemented our safety system, we also want to collect data to ensure that we're meeting our assumed frequencies of testing, that we're doing our repairs within the time that we've specified, and ultimately meeting our safety integrity requirements. So let's take a walk through the life cycle and look at when and where and how we're defining these different proof test parameters. In the analysis phase of the life cycle, we're going to start with the process hazard analysis that helps us to determine what high-risk scenarios we might have inherent in our process. We document the cause of this hazard as well as its likelihood. We document the consequence of the hazard and its severity. And we document any safeguards we have in place to avoid the hazard or to mitigate its consequence if it were to occur. These safeguards include safety instrumented functions. And for high-risk scenarios, we're going to move on to do layer of protection analysis and SIL selection to determine the integrity requirements we need to meet in our safety functions in order to meet a tolerable frequency for that hazard scenario. So through LOPA and SIL selection, we're determining our target risk reduction factor and our target safety integrity level. And we'll hand this off to the person designing the SIF in SIL verification so that they know exactly what requirements they're trying to meet in that SIF design. The way we hand off those requirements is through the SRS, or the Safety Requirements Specification. And here you can see a screenshot of our SRS module, which provides a template with a field for every single one of the requirements that the standard asks us to include so that the design team has all of the information at their fingertips to know exactly how they need to design the SIF. It will include the hazards the SIF is supposed to be responding to. It will include the preliminary SIF architecture, as well as information on the types of devices needed. And it will start to define that proof testing strategy. So here in the screenshot, you can see desired proof test intervals for the sensor part, logic solver part, and final element part. And this is communicating the design team how often we would expect to have to go out and test these devices on site. Here you can see for the sensor and logic solver, we're assuming an annual test is done, but for final element, every 6 months we would be testing those devices. This is used as an input into our SIL verification, and we might have to even change the intervals in order to meet our target SIL and our target risk reduction factor. So that is why here it says desired proof test intervals. The SRS is a nice way to hand off all of the information from the analysis phase to the person doing the design. And so this is just the start of defining our proof test strategy. After that is complete, we're going to move on to the design and implementation phase. And this is where we address a lot of the parameters that create our overall proof test strategy. As we're designing our SIF, we're going to model the SIF architecture, including any redundancy we have within our SIF. We're going to select SIF devices, and we're going to start to input a lot of parameters that give us an idea what type of maintenance and how frequent that maintenance is of the devices within your safety instrumented system. And so let's take a look at what some of those parameters are. If you're familiar with Silver, you know there are a lot of inputs that address the mean repair time or the mission time of your SIF devices. The mean repair time is how quickly you believe that after a failure, you can repair your SIF device and bring it back online. The mission time is the time you expect your SIF to be in service before all of the devices are fully replaced or refurbished. In addition to those types of maintenance parameters, we are going to define quite a few things regarding this proof testing or this manual test. The first one, as we mentioned in the SRS, is the proof test interval. So here is where you would actually input the interval you want to assume within your Silver calculation. And we'll show you exactly the impact that has on the results. The interval is the time between your proof tests or functional tests. And so here in the screenshot, you can see an input of 4 years. That means after your initial proof test, you're going to have 4 years before your next. And so that's the time between your tests. Another parameter we're interested in is this test performed while your system is online or offline? In some cases, we have sites that have outages and make sure to do all of their testing while their system is offline. Perhaps you have a batch process, and so you're doing the tests between batches. In other cases, the test has to be done while the system is online. And in that case, we have a few other parameters we'd like to understand. One is, what is the duration of the proof test? How long does it take to perform the procedure? Obviously, when you're testing SIF equipment, it has to be put in bypass. So during that time, you wouldn't have the SIF to protect you against a hazardous scenario. It wouldn't be able to bring the process back to the safe state while it's bypassed. So we want to understand for how long it's in bypass. And also, do you have any alternative protection in place to bring the process back to the safe state while the SIF is being tested? For final elements, we have additional proof test scope that you can indicate if you're doing a leak test or if you're testing at operating conditions. This is going to reveal more dangerous undetected failures than if you were simply doing a full stroke test for your final elements. And so this is going to help us understand the effectiveness of your proof test, which will up the proof test coverage. All of these parameters have a big impact on the results of your SIL verification. And so let's talk a little bit about exactly how this is going to affect your results. In Silver, once you've modeled your SIF, you always have access to these PFD charts that is going to show you the probability of failure on demand of your safety instrumented function over time. And so this red line is showing the probability of failure on demand once you've installed your system and it's online. And the trend is always that it increases over time. Except you see these dips in the trend anytime you do a proof test. So in this first chart, you're seeing an annual proof test or a 1-year proof test. And so you see that dip in the trend of your probability of failure on demand every year. We see that this chart is showing us 10 years, since that is the mission time specified, and we have an average of our PFD taken over that mission time. So that is signified by this dotted line. This is showing us our PFD average result, which directly affects our achieved SIL level. And so if we contrast this with the trend of a proof test done every 5 years, you see that the probability of failure on demand is increasing over the first 5 years, then it dips for that one proof test that's done at 5 years, and then continues to increase. And you see that our average is quite a bit higher than it is when we're doing an annual test. So a higher proof test frequency is going to result in a lower PFD average. Now, obviously, there are other considerations when it comes to how frequency you're doing your proof test, including the cost of doing the proof test, especially if it requires an outage. So you have some loss of production costs there. So we want to do proof tests frequently, but within reason, so that we're not constantly shutting down our plant or spending the time and materials needed to do that test. Another parameter we talked about was proof test effectiveness, and this is some of the data we're going to get from our SERH, or embedded database within exSILentia. If you're familiar with Silver, you know that it's very easy as you're modeling SIF to choose equipment from our SERH, or Safety Equipment Reliability Handbook. And that device information includes failure rate data. It also includes useful life and a proof test coverage. The basis for the proof test coverage in the database is the procedure that the manufacturer provides in their safety manual. So we look at the procedure and we determine how many dangerous undetected failures can be revealed by using this procedure. And that helps us determine the proof test coverage. So when you select a device from the database, it's not only automatically applying the failure rates to your calculation, but also automatically applying this proof test coverage. That means it's pretty important to understand what that procedure is. Perhaps on site, you're not doing all of the steps included in that test, or perhaps you're doing more and your proof test coverage should be increased. And so when it comes to proof test effectiveness, the scope of your proof test, you want to make sure you're comparing it to what the manufacturer suggested within the safety manual. This is easy to do with our embedded database, because when you select from the SERH and you look at your device model, it actually has the proof test documented right within exSILentia. So if you have a Silver license and you go into the library and you select device models, for each you should see an associated proof test. Now, these are very high-level generic proof tests, meaning that they don't include any application or site-specific information. But they do include the steps that you need to take in order to properly test your SIF device to reveal any dangerous undetected failures. So we know the basis of our proof test coverage, but it's also important to understand the impact this has on our overall Silver results. If we take a look at our PFD charts, here you can see a chart for a proof test coverage of 95% and a chart with a proof test coverage of 80%. So given consistent failure rates, you see there's very obviously difference in the trend of PFD over time. For each, you still have a dip at 1 year, but for 95%, you can see that it's a more effective proof test, dipping further down. For 80%, you see that the PFD average is a little bit higher than it is for the 95%. This is really based off of the device itself. So for some devices, you might not be able to have a more effective proof test than 80%. It really depends on what dangerous undetected failures can be revealed during that test. That said, if you are able to increase the scope of your proof test in order to make it more effective, you can override our equipment data, you can input a higher proof test coverage, and you'll see your PFD average is lower in that case. Earlier, we talked about final elements and how typically we assume that you're able to do a full stroke test during a manual proof test. But you can also add on the scope of a leak test or performing that test at operating conditions to make it more effective, to ultimately reveal more dangerous undetected failures and increase that proof test coverage so it positively impacts your overall results. It's always nice to revert back to these PFD charts in order to see exactly how the parameters that you're inputting affect your results. If you have an online test with no alternative protection, you're going to see that although the PFD ultimately dips, during the time that test is being performed, your PFD is 1, meaning that if you have a hazardous scenario occur, your SIP won't be able to bring the process back to the safe state. It's certain to fail. And so you'll see the impact of doing online tests on your overall PFD average just as much as you would the proof test effectiveness or the proof test interval. So you see how important these parameters are to your SIF design and ultimately to your achieved SIL and your achieved risk reduction factor. And so we want to make sure that going into the O&M phase, we're carrying out these maintenance tasks just as we specified in our calculation to the best of our ability. This is why we have what we call Site Safety Index within exSILentia, because we know that on site it's not always the easiest thing to carry out our maintenance to the letter of the law all the time. But our practices at site do impact our proof test interval, our proof test coverage if we're doing the entire procedure, what that scope of the procedure is. Our proof test duration, which is an assumption we make in the tool, may vary on site, and our mean time to restore or repair. So obviously, mean time to restore is our mean repair time plus our mean detection time. For proof testing, at a specific interval, we're able to reveal failures that impacts our mean detection time. But also, how quickly are we able to repair the device and bring it back online if our proof test results in a failure? So our practices on site determine what actual safety integrity we're meeting for our safety instrumented system. And the failure rates of a specific device will change from site to site based off of site practices and how well they're able to keep up with these tasks. So within exSILentia, we do have what we call Site Safety Index, and this is a qualitative way to look at how often these tasks are performed as they were specified within the design. So we have 5 different levels from SSI 0 to SSI 4 that help determine exactly what the practices on your site are and how they might impact your results in silver. We find that on average, people are at SSI 2, and so that's our default, where repairs are usually completed correctly, testing is performed correctly and mostly on schedule. Most equipment is replaced before the end of the useful life. This is a little different than perfect, where everything is always completed correctly. Testing is always performed correctly and on schedule. Equipment is always replaced before the end of the useful life. This is going to put a bit of a factor on your repair rate and your Markov model for your calculation. And so it basically gives a way for you to consider exactly how your on-site practices impact your silver results. If you're not sure what your on-site practices are, we do have a Site Safety Index Estimator questionnaire. This is within the project configuration. You're able to go through, and again, it's just a qualitative look where it provides you with questions about how you're carrying out these tasks on site and allows you to say if you're always doing something, often doing it, or never rarely doing it. You're able to specify this separately for your sensors, your final elements, and your logic solvers, because we know that at times we're able to access certain equipment better than others in order to test. Perhaps we have more mature or detailed proof test procedures for certain types of devices and not others. And so you're able to have that granularity when you choose Site Safety Index. If you prefer not to consider this within exSILentia, you can assume that it's perfect, but it's good to read exactly what we would expect from SSI 4, which we call perfect repair. As I mentioned, you'll see it default to SSI 2, assuming that you're keeping up with this and, at times, things aren't always done completely to schedule. Once our SIF design is completed, or if we're struggling to meet our targets, it's nice to take a look at our lifecycle cost estimator. This helps to consider the cost of your equipment devices for your safety instrumented function, how redundancy impacts those costs, and also how the maintenance tasks that you're doing on site impact the overall cost of your SIF. And so you're able to use this module to optimize your SIF design. Obviously, we want to reach our safety integrity requirements, but we want to optimize to consider cost as well. So it will take into account the equipment costs of your equipment, as well as the cost of performing the proof tests, doing routine maintenance, decommissioning, and also spurious trips, because every time our plant trips unnecessarily, there is an associated cost to getting it back up and running. So the proof test frequency is going to be an important parameter when looking at the cost of your proof testing, since you have to consider personnel and materials to do that proof testing. And each time you do it, it's going to incur that same cost. If you're having trouble meeting your safety integrity requirements, you might have to decide, should we add redundancy within our SIF, or should we do more frequent testing of our SIF? And this module is going to help to understand which has a larger impact on your overall costs, to ensure that you're able to consider that as well as meeting your SIF design requirements. Finally, once your SIF design is completed, you're able to communicate requirements for implementation using the design SRS. So much like the SRS in the analysis phase, we want to make sure that now that we've finalized the SIF architecture, what devices we're implementing for our safety instrumented function, and what our maintenance strategy and proof test strategy is. We want to document that in a nice templated specification so that the people implementing the SIFs on site or carrying out the maintenance tasks have an easy way to access the requirements. So this is going to communicate the finalized proof test coverage, proof test interval, and proof test duration for your proof test strategy when it comes to each of your SIFs. A lot of the information in the design SRS is pulled straight from Silver and your inputs there, but it does allow you to include more device-specific requirements and more maintenance information now that you know exactly what your SIF is going to be. Finally, we want to make sure that we have proof test procedures ready to do the proof testing on site. So creating these procedures is important because we know that our proof test coverage is based off of the procedure within the safety manual. So we want to make sure that we're accounting for the steps in those procedures, as well as adding appropriate guidance for the people on site who have to carry out these tests. So you'd want to make sure from a device perspective that you're doing the right procedures, but also make sure that these procedures are comprehensive. You can do that with our proof test generator, which, based off of your selections from Silver, provides to you the high-level proof test that is required from the manufacturer's safety manual. It provides these steps as what we would call suggestions. So because they're individual tests, you might see a direction to bypass your safety instrumented function and then take it off bypass every single time. If you're creating a full safety instrumented function proof test where you're doing a full loop test, you might not want the put the devices on bypass and take the devices off bypass steps in every single section of your proof test. And so we want to make sure you have access to the proof test steps, but that you're able to apply them in a way that makes sense to the proof test scope that you're looking at and to the site information that you want to make sure you're communicating. Here you can see the proof test suggestions. You're able to apply them all at once to our proof test editor, or you're able to apply them one at a time. And this allows you to have the flexibility to ensure that your proof test coverage is valid because you're doing the important steps to reveal any dangerous undetected failures, but also that you're not repeating anything unnecessary. The proof test editor also allows you to add as many additional steps as you want in order to give comprehensive guidance to the people on site performing the test. And this includes an ability to add as many different steps as you like. The steps can be just text direction, or you could also prompt the person performing the test to input any values associated with the step that you're doing. These can be number values, they could be selections within the test. You're essentially setting up pass-fail criteria that can be used to determine easily if there's a failure within the device and if the test passes or fails. And so the editor is pretty flexible to allow you to add as much detail as needed and that pass-fail criteria. And the proof test generator within exSILentia is pulling all of this from your Silver selections. So this assumes you've already modeled your SIF, you've chosen your SIF architecture, you've chosen your SIF equipment, and we're able to provide suggestions that way. You have the ability to say if you want the proof test scope to address a single device at a time, or the entire SIF. So you're able to configure the scope in that way, and it will provide you with the suggestions which you can then use to build your proof test. Once your proof tests are finalized, you'd be able to generate a report of your proof test procedures in Microsoft Word or import them into an operation and maintenance tool that will help you keep track of your maintenance activities. In our case, you can import into Silstat. Silstat is going to remind you when proof tests are up and coming. It will allow you to perform the proof test within the software itself, prompting you for any pass-fail criteria associated with each step in the procedure, and ultimately telling you if there is a failure in your device or not. For tests that reveal a failure, you're able to then record corrective actions, whether it be a repair, a replacement of the device, or decommissioning of that device. And so all of this is allowing us to easily conduct our proof testing within our Silstat software. I mentioned import. The first step you're going to do is transfer your project data into Silstat. If you've defined your proof test within exSILentia, you'll see in the library a proof test section, and this will list all of your proof tests associated with your SIFs in your project. This can easily be transferred to Silstat, where we have a similar library that says procedures. It will list each one that is a proof test, as well as the scope of the test itself, whether it be a full loop test for your SIF, whether it be testing the group or the leg or tag. The reason we have a type is because within Silstat, you can also add other procedures for routine maintenance, whatever it may be, whether it be maintenance on a SIF or maintenance on other safeguard equipment within your system. Once you've imported this information, it will allow you to specify the date that the equipment was installed, if that was in the past, or whether you're installing it on a greenfield site now. And it will then remind you when your proof tests are due based off of the proof test interval specified. When you complete a test within Silstat, or if you are keeping track of your tests elsewhere and you have it a third-party system that's integrated with Silstat that indicates that you completed your tests, it will then automatically update the due date for the next test based off of your proof test interval. So reminders are available in-app, via email, and via the dashboard. Here you can see a screenshot of our dashboard that is showing us that we have some proof tests up and coming over the next few months, and also an indication of how many of our tests are completed on time, how often the interval is exceeded, and if the proof tests are completed, overdue, or pending. These widgets are going to give an at-a-glance indication of how you're performing your proof test, whether you're often on time or overdue. If you're getting a notification that a test is due, it's easy to navigate to that test within your plant hierarchy or within the library and initiate performing the test within the app. This will provide you with the proof test steps, any additional descriptions that are needed, and allow you to enter any values that were created as pass-fail criteria, whether that be entering a number, whether that be describing the state of a device, or anything else that might be important for that particular procedure. You're also able to associate any documents, whether they be device drawings, any pictures of the physical state of the device, perhaps your P&ID sheet that's associated with your proof test procedure. Anything like that can be included with the step in the proof test event. Once you've completed all of the steps, Silstat will indicate if the test passed or failed based off of the pass-fail criteria you defined. If a failure was revealed during the test, the tool will then prompt you to record a corrective action. So that would be a repair event, a replacement event, or perhaps you're decommissioning that part of the safety instrumented system. All of this can be done within the tool so that you're able to trace through exactly when the test was performed, what the failure detail is, and what the corrective action detail is. Over time, this is going to help to validate some of the parameters that we specified in order to get our SIL verification results. So that includes the interval that you're doing the test at. Here in a widget, you can see a event history for the proof tests that have been done within our database in Silstat. Here you can see the interval that we specified in silver, what we're calling our target interval. This is what you will be reminded to perform. And then you'll have an actual interval to say, hey, you know, your proof test interval was 12 months, but you seem to be doing it at month 13 or 14. You seem to be overdue by this amount of time. It will also show you a pass rate. So how often is this proof test passing or failing? Along with the actual versus assumed proof test interval, you also are going to be able to see what your actual versus assumed mean repair time is. Since we're able to document when you perform the test and became aware of a potential device failure, and then how long it took to repair the device and bring that SIF back online. And so we know that's another one of the important parameters in our SIL verification, and Silstat will help us keep track of that. In the event there is a failure revealed by a proof test, you also are recording the failure detail. And so this is going to help us to compare our actual versus assumed device failure rates that are used in Silver. Over a good number of operating hours, you will actually be able to see that the failure rates that you are experiencing on site and compare them to the ones that we've assumed in the SIL verification. So what is shown here is just one example of our preset widgets. Here you can see that even in this widget, we have other tables embedded to provide context on your proof test records. So we have procedures upcoming, procedures completed, procedures overdue, and then the summary you're seeing here. If you're interested in more detailed records on your proof test activity, you would be able to generate one of our reports, which will be generated in Microsoft Word to see more of the event history and the detail for each event. These can be pretty long reports because you decide the scope that you generate the report for. So you might be looking at a SIF or a particular equipment, unit, or process area. And so depending on the scope, there is a lot of information to report out, and you can do that with those reports. If you're just looking to view your data at a glance in context, you would use the dashboard for that. And ultimately, you want to take that data to approach your revalidation. So say when you do your SIL verification revalidation every 5 years, you would be able to now approach that with this data in hand and input the parameters such that you know how often you're doing your proof testing, you know how fast you can do a repair, you know when you're ultimately changing out or repairing your equipment at the end of the mission time. And so to be able to take a look at that site data and input that into Silver, you're going to get a more accurate result about what is actually occurring on site. And so you might find that you are not meeting the safety integrity targets that you had initially. You're not meeting your target's risk reduction factor, your target SIL level. And so you would want to make adjustments to that, whether it be adjustments to your SIF design, to your maintenance approach, or perhaps you have to on-site make sure that you're able to keep up with these maintenance tasks more effectively. On the other hand, you might find that you are meeting or exceeding your safety integrity requirements, and in that case, you might find some opportunities for cost reduction. Perhaps you don't need to do such frequent proof testing in order to have the same level of safety integrity that you were aiming for in the first place. You also see proof test generator here is highlighted. You can always review your proof test procedures to see how you can make them more detailed to help those on site who are carrying them out, or to make them more effective by adding scope to the procedure that would help to reveal more dangerous undetected failures. And so with that, we've really completed the full life cycle from PHA to the operation and maintenance tasks, collecting data on that so we can revisit our revalidations with site-specific data to make our design more accurate and reach our safety integrity requirements. And by really honing in on this proof test strategy, we're able to ensure that our safety system can effectively respond to any hazard scenarios in order to ensure that our sites are safe. We want to make sure that our personnel is safe, that our equipment is not being damaged, and that we're keeping the environment safe. And so with that, we've taken a look at all of the proof test tasks in the functional safety lifecycle. I welcome any questions you have on what we've reviewed today, whether it be a task or one of the software tools I used as an example in order to carry out that task. So please feel free to reach out to me with any questions. I hope that this was a helpful webinar. And with that, take care. I hope to see you again soon.